Welcome to our final geometry lesson for the year. This one will cover 19.3, the volume of spheres. Here in the warm-up, they ask us for two things, the volume and the surface area of the pyramid. Let's do volume first. That's an easy one. That's our formula from yesterday. That's going to be 1/3 area of the base times the height. Well, we've got our 1/3. The area of the base, well, the base is a square. It's 5 by 5. And 5 by 5 is 25. And then here's the height. The height is 3. And if I do 1/3 of 3, that's 1. 1 times 25 is 25. And our units there would be meters cubed for our volume. And now let's do the surface area. When we look at this pyramid, the surface area, we're going to have a square base, and then we're going to have 4 triangular sides. Our base, we saw when we did volume, our base is 5 by 5, so our base there is 25. And then we're going to add to that 4 triangles, and each triangle is 1/2 base times height. So let's do the 4 times the half. Well, that's just 2. The base here, if we look at this one side here, our base would be 5. And now we need to find the height. So that's this slant height running up the pyramid. So it looks like we're going to have to break this off and make a right triangle. Our height here is 3. The base of this would be 1/2 of 5, or 2.5. And then our hypotenuse, let's just call it c. So we need c squared equals 3 squared plus 2.5 squared. And that is 9 for 3 squared. 2.5 squared is 6.25. And if we add those up, c squared is 15.25. When we take the square root of each side, c is about 3.91. So that's going to go in right here for h, 3.91. Okay, so again, we don't want to lose that 25 from the base. 2 times 5 is 10. 10 times this, we just move the decimal over 1 point. So that's 39.1. And then our surface area is 25 plus 39.1 is 64.1. Our units here would be squared meters. Meters squared. All right, now let's get into today's lesson. Here it says watch the video. I don't have the video available here, but it talks about the volume of a cone compared to the volume of the sphere. So this is something we can do just in the video. Cone and SPH, cone and sphere. Yesterday we knew that a cone is 1/2 times the base pi r squared times the height. The sphere, we're about to see this on the next slide. The volume of a sphere is 4/3 pi r cubed. Now here I'm going to underline in blue how many cones equal the volume of a sphere if the radii are equal to the height of the cone. The radii are equal and the height of the cone is equal to the sphere's diameter. So here in the cone, the height of the cone is equal to the sphere's diameter, and the diameter is twice the radius. So I'm going to take this h that I'm covering in blue ink, and I'm going to replace it with a 2r. So now we've got 1/3 times pi times r squared times 2r. Well, I could multiply this 2 by the leading 1/3 fraction. I put the 2 up there. Now that's 2/3. And I've got an r squared times an r to the first. So that will be r cubed. So now let's look at these. On the left here for the cone is 2/3 pi r cubed. And that should be equal to 4/3 pi r cubed if we just multiply this side by some constant. Well, the pi's are the same and the r cubes are the same. So what would I multiply 2/3 by to get 4/3? Well, that would be 2. So we can get 2 cones from one sphere as long as the radii are equal and the height of the cone is just equal to the sphere's diameter. All right, so now volume of a sphere. We are missing a word here. The volume of a sphere with radius r. is given by volume equals 4/3 pi r cubed. We just need the radius, we plug it in, and we can find the volume of any sphere. And let's try that out here in example 2. In example 2, it's a full sphere, and they've given us the diameter. So we are going to cut that in half. Our radius is 6. They do say here at the end, leave answer in terms of pi. So the volume of 2a is 4/3 times pi times 6 to the third power. 6 to the third is 216. And if I was just doing this on a calculator, I would do 216 times numerator 4, divide that by denominator 3, and you should get 288, and we'll attach our pi to that number. 288 pi, our units would be feet cubed. Now in letter B, we've got half a sphere, a hemisphere. So our formula is 4/3 pi r cubed, and we're going to multiply that by a half. So I could just multiply my fractions here, and that would be 4/6, and 4/6 reduces to 2/3 pi r cubed. So we're just going to plug in r as 9, so that'll be 2/3 times pi times 9 cubed. 9 cubed is 729 times pi. So I would punch in my calculator 2 times 729. I would divide that by 3, and that turns out to be 486 pi. Units are millimeters, so our volume is millimeters cubed. That wasn't too bad. Now let's look at this one. We've got in example 3, a BTU, also known as a British thermal unit, is a common unit in the U.S. to measure the amount of heat energy or heat capacity used. This spherical propane tank shown in the picture is full of propane. Part A, it says, what is the heating capacity of all that propane in these British thermal units? And they tell us, I'm going to highlight this, 1 cubic foot is 2,516 BTUs. So first part of A here, find the volume of propane in our tank. Well, that volume is 4/3 times pi times our radius, which in the picture here tells us it is 30 feet. So that'll be 30 cubed. So we would cube the 30, and that would be 27 with 3 zeros after it. And we're going to multiply that by the 4/3. And that will be 36,000 pi feet cubed. So there's the volume of propane in the tank. Now the next part here, find the number of BTUs. Well, that we're just going to take our volume, 36,000 times pi cubic feet, and we're going to multiply it by this highlighted number, so times 2,516, and on the calculator we'll use the pi key here. So if we multiply that straight across, we should get 84,311.97 British thermal units. All right, that's a pretty big tank. We got some pretty big... well, for this... Back up. I screwed up. I was looking at ahead of my notes. Back that up. So the 36,000 pi times the 2516, that was right. But when we multiply that, we're going to get 90,576,000 pi. And when we multiply with the pi key, the answer is 284,552,896.2 BTUs. There we go. That's a huge number. It is a huge tank with a 30-foot radius. Now in part B, we're going to work with a little smaller tank. So in part B, now our tank just has a radius of 2 feet. So a little easier number to work with. I'm going to sneak up here to do the volume. Volume is 4/3 times pi times 2 cubed. Well, 2 cubed is 8, and we could multiply that by the 4. That'd be 32, and we're going to divide that by 4. So that's going to turn out to be 10.6 repeating pi. Our units here would be feet cubed. So 10.6 repeating feet cubed of volume. And now we want to take that 10.6 repeating times pi. We're going to multiply that number by the 2,516 for the British thermal units. And that's the answer I mistakenly gave just a little bit ago, 84,311.97 BTUs. All right, there we go. Now, we worked with a propane tank. Here in example 4, we've got a tree. It's got sort of a round spherical-shaped canopy. So consider the tree shown. Diameter is 25 feet. So obviously the radius will be 12.5 feet. Estimate the volume of the canopy of the tree. So our volume is 4/3 times pi times 12.5 cubed. And 12.5 cubed is 1,953.125. And then I would multiply that by the 4/3, and then I would multiply that by pi, and we get 81.23 cubic feet. So 8,181.23 cubic feet is the volume of the tree's canopy. In part B, we got a landscaping company shows up. They trim the tree. The canopy is still a sphere, but its new volume is less, 5,000 cubic feet. What is the diameter of the canopy after the trimming? So we are going to use, I'm going to write it up here, our volume formula, 4/3 pi r cubed. But now we know the volume is 5,000. So that's 5,000 is equal to 4/3 times pi times some radius cubed. So to get the r cubed alone, we're going to take the 5,000 and divide it by 4/3, which is the same as multiplying by 3/4. And then we're also going to divide by pi. So I'm going to put that pi under the 5,000. If I was doing this on the calculator, I would do 5,000 times 3. Get that answer, divided by 4, and then divide that by pi. And that's equal to r cubed. So if we do this over here, 3 times the 5,000, divide that by 4, divide that by pi, we should get r cubed is 1,193.66. And there is a cube root key on the TI-30 calculators. That should work and give us a radius of approximately 10.6 feet. But let's go back and read the question again. What is the diameter of the tree? So this is our radius. To get the diameter, we're going to have to multiply that by 2. So that would be approximately 21.2 feet for our new diameter. Okay, now this part C takes another twist on our tree here that we're trimming. When the diameter of the canopy grows to 24 feet, it will be trimmed again. So it's going to grow to 24, it'll get a huge volume, and then how many cubic feet of the canopy must be trimmed away? So we cut back to 21.2 feet. Well, I'm going to use blue ink, and this right here was our volume was 5,000 cubic feet. So we're going to figure out our new volume with the 24-foot diameter. We'll find that volume, and then we'll subtract the 5,000. So let's do our volume here. Now our diameter is 12, so the radius, or our diameter is 24. Our radius will be 12. Volume is 4/3 times pi times 12 cubed. Well, 12 cubed is 1,728. So I'd multiply that by 4. I would divide that by 3, and then multiply by pi. And our 24-foot diameter gives us a volume of about 7,238.23 feet cubed. So again, that's our volume when our radius grew to 12 feet or our diameter 24. And the question again is how much must be trimmed away to get back to the 21.2 feet diameter? So we are going to subtract that 5,000. And when we subtract, that means we're going to need 2,238.23 feet cubed must be trimmed. Must be trimmed. All right. Example 5. We've got an ice cream cone looking shape here. We saw some stuff like this yesterday in the surface area. Now it says find the volume of the composite figure. Volume equals half sphere. So the half sphere is sitting on top plus a cone. All right, let's think of our formulas. We got our 1/2. Our sphere is 4/3 pi r cubed. The cone, remember the volume of a cone is area of the base times the height. Well, a cone's base is a circle, pi r squared, and we're going to multiply that by its height. So let's see here. Let's do the same thing with the 1/2 and the 4/3. That'll be 4/6 or 2/3 times pi times the radius. Now here on the picture from the center here up to the top is 7. Remember, it's a sphere. So that would also be our radius to the left as well as our radius to the right. So our sphere radius has to be a 7. So that'll be 7 cubed. And then we've got our cone, pi, same radius, 7. That'll be a 7 squared. And then our height is handed to us right there. That's a 24. So let's see what we got here. If we cube the 7 and then take 2/3 of it, I believe we get 392 pi plus, hold on, back up. I think I'm looking at that wrong in my notes. No, this one would be 228.7 pi. And then the 7 squared is 49. 49 times 24, that's the 392 pi. Now, I would just add those together and then multiply by the pi key. We should get a volume of about 1,949.9. Our units are centimeters, and they're going to be cubed. All right, I believe that's the last example. So here's a great spot. Pause the video, try these practice problems, and then start the video back up. See if you got them right. Okay, the first one's not bad. It's a lot like example 1. A sphere and a hemisphere. In our first one, they did hand us the radius. So our volume will be 4/3 pi times 5 cubed. Well, 5 cubed is 125. So we're going to multiply 4 times 125, divide that by 3, and that is, it does say leave answer in terms of pi. Our volume there is 166.6 repeating pi. Units are centimeters, and they will be cubed. All right, in the second one, we've got a hemisphere, and they gave us the diameter. So our radius there is going to be 3. Our volume will be 1/2 times 4/3 pi times 3 cubed. Oop, that's an ugly 3 cubed. Let me fix that. 3 cubed. All right, well, the 1/2 times the 4/3, that's 4/6 or 2/3 times pi. 3 cubed is 27. So 27 times 2 is 54. 54 divided by 3 is 18. So that'll be 18 pi. Units are feet, and they're cubed. All right, again, that wasn't bad. In example 2, we've got somebody making a model of Earth out of paper mache. The diameter of the model is 13 inches. That means our radius will be 6.5. What is the volume of the model? Round to the nearest tenth of a cubic inch. So once again, volume is 4/3 pi times the 6.5 cubed. So that's 4/3 times pi. The 6.5 cubed turns out to be 274.625. All right, and they don't say leave it in terms of pi. They actually do say round to the nearest tenth of a cubic inch. So my calculator told me 1,150.35, so we'll round that up to a 4. Units are inches, and they're cubed. All right, 2 wasn't so bad. Number 3, we got a homeowner with a propane tank installed with the dimensions shown. Tank is filled with propane. What is the heating capacity of this propane in our BTUs? Round to the nearest whole number. And again, they give us that 1 cubic foot is 2516 BTUs. So we do have a hemisphere on each side of this tank. So our volume will consist of a complete sphere, 4/3 pi r cubed. And then we're going to have the volume of our cylinder. The volume of the cylinder is pi r squared times the height, or in this case, the length of the tank. So volume is 4/3 times pi. Nice here. Our radius is just 1. 1 to the third is just going to be 1. That'll make this a little easier. And then here we're going to have pi times 1 squared. The height or length of this tank is 8. So let's see what we got here. 1 cubed is 1 times 4/3 is just 4/3 pi plus 8 times 1 squared is 8 times pi is 8 pi. So here I would just start punching this in the calculator. You could sort of factor out the pi and do 4/3 plus 8, add that together, multiply that by pi, and we should get approximately 29.322 feet cubed. And we're not done with the problem yet because we do want the amount of BTUs in there. So we're going to take that answer, 29.322. We're going to multiply that by the 2,516, and we should get 73,773 British thermal units. What's next? Number 4. Another sphere that has the volume given, and they're asking for the radius. So once again, we're just going to use volume is 4/3 pi r cubed. Our volume is given as 2,482. That's equal to 4/3 times pi times our radius cubed. So I'm going to bring down the 2,482. I'm going to put it as a fraction over 1, because again, we could divide both sides by 4/3, and dividing by 4/3 is like multiplying by the reciprocal 3/4. And then we're also going to have to divide pi out, so I'm going to just turn this 1 in the denominator into a pi. And that would make this pretty easy to punch into a calculator. I would just multiply my numerator, 2482 by 3, and then divide that by 4, and then divide that by pi, and that will be our radius cubed. And my calculator said 592.534, and I would just use the cube root button on the calculator. And that tells me it's 8.399, and it does say round to the nearest tenth. So that's real nice to round to 8.4. Units are inches. Now, part B is real easy. What's the diameter of the sphere? Well, we just found the radius, so we're going to take the radius, 8.4, and we're going to double that and get 16.8. Inches equals D for diameter. All right, we're getting close. Just a few more to go. Number 5. Jenna has a scoop shaped like a hemisphere. She's filling the scoop with water and dumping that water into the bucket that is a cylinder with dimensions shown. How many scoops of water to fill the bucket? So we're going to find the volume of the sphere, and we're going to find the volume of the cylinder and see how they compare. So our sphere is actually a hemisphere. So that's going to be a half times 4/3 times pi r cubed. A half times 4/3 is 4/6, or 2/3, times pi, times the radius 6 cubed. So that turns out to be 36 pi. Oh, no, not 36. That would just be sort of the numerator. We would have to, yeah, that would be half of that, actually. Back up. So not 36. 6 cubed times 2 and divide that by 3. Yeah, that would turn out to be 18 pi. 18 pi. Now let's look at just the cylinder by itself. The cylinder is pi r squared times h. That's pi. Our radius is 6, so we would square that and get 36. Our height is 10, so 10 times 36 is 360. So we got 360 pi. So we've got, if we look at our cylinder, it's full of 360 pi cubic inches of ice cream. And we're going to divide that by our scoop. That's 18 pi. And the pi's will cancel. And 360 divided by 18, that turns out to be a perfect 20. So 20 scoops. All right. Number 5. Done. Number 6. Find the value of each composite figure. Round your answer to the nearest tenth. Well, I guess that wouldn't be the value. That would be the volume of each composite figure, and then we'll add them together. So let's see. We've got a prism, a rectangular prism. That'll just be length times width times height. And then we're going to add to that a hemisphere, or a half sphere. So our sphere is 4/3 pi r cubed. And again, we're just going to add those values together. So total volume. Down here, we're going to multiply the length and the width and the height. The order is not important. 11 times 8 times 3. And then we're going to add to that our half sphere. And I guess I need the half in front of the 4/3. So that's going to be 4/6, or 2/3 pi r cubed. 2/3 times pi. Our radius is 2, so that'll be 2 cubed. So if we multiply all of our length and width and height here in the prism, that turns into a 264. And then 2 cubed is 8. 8 times 2 is 16. So that'll be 16/3 times pi. And my calculator said 16.755. If I add those together, I should get 280.8. Our units are meters, and they would be cubic meters because it's volume. Okay, last one. Dawn states if you double the radius, you double the volume. Is she correct? Let's find out. So let's look at here. I'll use black ink. Volume is 4/3 pi times r cubed. All right, now if we double the radius, I'm going to sort of put this in its own set of red parentheses. If we double the radius, our volume would be 4/3 pi times 2r cubed. All right, now we've got some stuff in grouping symbols, parenthesis, so remember our order of operations, PEMDAS. We're going to work in the parenthesis first, and that is 2r quantity cubed. So it's kind of like we're multiplying 2r times another 2r times another 2r. 2 times 2 times 2 is 8. And then r times r times r is r cubed. And now I'm going to rewrite this, but I'm going to move that red 8 to the front. So if we had a radius here, that would be our volume. And if we double the radius, now we have 8 times this. So here, doubling the volume gave us 8 times, or doubling the radius gave us 8 times the volume. So Dawn, not very correct. That's our last practice problem. That's the end of the video, and that is the end of geometry for this year. I hope you had a good time.